Yeah, so welcome all. So this is just a following video. Okay, so last video we looked into that what is the importance of gate, and just we briefed that what are the opportunities after gate, like what is your valid gate score for your M.Tech and all these things, for your PSUs, various PSUs, what is the valid gate score for the valid PSUs. तो ये सब चीज़ हम लोग देखे थे, ठीक ना. And then what we did is that we announced our crash course. Okay, we announced our crash course, that is from our gate forum for the last 3 months preparation. So we announced our crash course, that is we said that it will be 100 hours crash course and it will be ended before 10th of January. Okay, and we said that the price, initial price will be 1,999 rupees, 1,999, and after first 50 subscriptions, then we will increase the price to its original price, which is nothing but rupees 3,999. So be quick in getting the subscription. Okay, for offer, like for the first 50 students, it is going to be 1,999. Okay, so let us leave this thing. So this video is just for like for the detail of the crash course. Okay, the detail of the crash course must be there. As you know that our crash course is starting from 15th of November. So the detail of the crash course, let us look into that, how we are going to cover the crash course, what all subjects we are going to start with, what is the sequence of these subjects. Okay, so and what are the content that we are going to cover, what are the topics that we are going to cover in the crash course, and how we are going to cover, what is the timing of the crash course, what will be the timing of the live classes, or what the live classes will also be provided to you in the recorded format, so you can watch it anytime according to your convenience. Okay, all these things. So let us look into this. Okay, so let us start. So first thing is that the starting date of your crash course is of 15th of November. The starting date of your crash course is 15th November 2023, of course. And one more thing, that your classes, will be held. Classes will be held between your 6 to 9 p.m. Okay, in the evening. 6 to 9 p.m. in the evening. We will have 1 hour or 1.5 hour or 2 hour classes as per our convenience, as per our need. Okay, so every day the classes are going to occur. The schedule you will get it on our social media platforms or our Telegram group. So be sure to join our Telegram group. The Telegram group QR code is given here. Just scan it and join our Telegram group. You will get the updates there about the schedule and all these things. Okay, so without wasting any time, let us just jump directly into the details of our crash course. Okay, so let us start. So we are going to start our crash course with the subject of mass transfer. This will be our first subject. That is, we are going to start it on 15th of November. And as we have discussed earlier, we are having 6 major subjects. So out of that 6 major subjects, each major subject is going to get 12 hours and the minor subjects are going to get 7 hours, like that. Okay, so what are the topics that we are going to cover in mass transfer? The first is your diffusion. Under diffusion, we will just understand the basic of the diffusion. Okay, what is diffusion, why diffusion happens, what are the major causes of the diffusion, driving forces of the diffusion, types of diffusion, all these things. We will solve questions on that. Okay, then we will also look into the molecular diffusion, that is your diffusion of A through non-diffusing B, and equimolar counter diffusion. Also we will look into unequimolar counter diffusion. All these topics, subtopics, we will look into diffusion. Okay, so after diffusion, then we will go to the second important topic, that is your absorption and stripping. Absorption and stripping. And in diffusion only we will cover our interface mass transfer. In diffusion only we will cover our interface mass transfer. Okay, the two film theory, the rest of the film theories, all these things. Okay, the less important topic we will cover it quickly, but the important topics like absorption and stripping, these things we will give time. Okay, after absorption stripping, we will be doing our distillation. Then next comes your extraction, humidification, drying, and at last we will do our adsorption. These are the basic plannings of your mass transfer. Okay, we will try to cover all the topics, and we will also solve questions, solve we will also solve numericals, which can give you a basic clear idea about the concept. Okay, like we will do a concept, we will see what are the formulas, we will see that how those formulas are derived in a very quick fashion, and then we will solve questions. Okay, it's like, so like this crash course is like going to be our main focus will be our numericals. Okay, through our numericals we will understand the topic. Okay, like we will get into theory, a little bit of theory, a little bit of formulas, when which formula to use, all these things we will be doing. And after that, the main focus will be our solving numericals. Through numericals we will have a better understanding. So after each topic we will solve 2-3 questions, so that we have a better understanding of the topic and the concept. Okay, so numericals, so we will solve numericals in such a way that we will cluster. Okay, we will form a cluster of concepts, and we will solve a numericals, so that based on one particular question, that one particular question will be having accumulation of one particular question is there. So in that particular question we will be having accumulation of 2-3 concepts or more concepts, so that based on that question you can solve further questions or your gate PYQs that has came in the gate. Okay, like that. Okay, after mass transfer, then we can start our CRE, that is our chemical reaction engineering. In chemical reaction engineering, first we will be doing our homogeneous system. In our homogeneous system we will be dealing with our kinetics, then we will be dealing with our ideal reactor designing, then we will be dealing with multiple reactions. Multiple reactions will involve your series, okay, parallel, autocatalytic, all these reactions we will be involved. Okay, reversible, yeah, we will do reversible. All these things we will be dealing. Based on this we will understand what is our yield, what is selectivity, in a very clear manner. Okay, once we do this, you will have face no doubt. Okay, this thing. Then after that, inside ideal reactor designing, there are just 3 reactors, so we will do all the 3 reactors, that is your batch reactor, your MFR, and PFR. Okay, and the kinetics we will do the basics like variable volume, CVRS, VVRS, constant volume reaction system, variable volume reaction systems, and your half-life, your fractional life. Okay, types of chemical reaction, all these things we will be covering under the kinetics. Once our homogeneous part is over, then we will move to our, what is the next part, that is your non-ideal reactor, that we will look into. Then we have some special kind of reactors like our semi-batch reactor, we have our recycle reactor, and when all these things are over, then we will also look into our heterogeneous system. So that is the basic idea behind our CRE. Okay, these are the main topics that we are going to cover in our CRE. And the same thing, we will complete a topic, we will understand the concept, we will look into the formulas, and directly we will do our questions. Okay, and one more thing, that all the things that we will be covering in the live class, I will provide it to in the Telegram group, the PDF of all these things. Okay, the PDF of the content I will provide it into Telegram group, so you can download it and you can use it for your revision purpose and all these things. Okay, so it will be a very efficient process. None of your time will be wasted. It will be a very efficient process. Okay, so after CRE we can start our heat transfer, or you want to start IPC, that we will see. We can start our IPC, that is instrumentation process control, or we can start our heat transfer also. Okay, so that we will see as per your demand, as per our discussion, we will take up the topic. Okay, the first topic that we will be starting is our mass transfer. Okay, IPC. So inside IPC we will look into our first order, then our second order system. Okay, before that we will look into our input, types of inputs like your step input, ramp input, impulse input, then your what else, kind of rectangular impulse input. Okay, all these things of kind of main inputs that are there, we will look into all these kind of inputs. Okay, then first order, second order, then we will look into our inverse response, then we can look into, okay, under second order only we have that condition law that when zeta will be less than 1, so there we will look into the decay ratio, all these things we will look into. Okay, then we will be doing inverse response, then we can go to our valves. No, then we can go to our valves. Okay, then we can go to our valves. After valves we will be starting our block diagram reduction and all these things. Very special concept or trick I will teach you. Okay, block diagram reduction and all these things will be there. This is nothing known as is modeling. This is known as your modeling thing. Okay, so this we will be doing. Okay, after this we can start our stability analysis. After that we can start our stability analysis, and dynamic response of first order also we will be doing. After the moderate modeling, no, we will be doing the dynamic response of first order. Okay, and after the valves only, no, like before starting this block diagram, no, we have to do our controllers also. So let us do our controllers before valves or after. Okay, we can do it just after inverse response, we can do our controllers. So your dynamic response of first order system means nothing. Suppose you have a first order system and we will apply particular controller like either P controller, I controller, D controller, PI controller, PID controller, or these kind of controllers we will apply to our first order system, and we will see that what are the changes in our space time and all these things. We will see like what are the changes in our, sorry, not space time, the time constant, the gain, okay, the offset, what are the changes that are occurring in these things, so that we will be looking into. Okay, for example, suppose, do you want to see an example? I wanted to make this lecture very short, but okay, we can see a example. For example, suppose what is your first order transfer function? It is kp by 1 plus tau ps. So this is your first order transfer function, no, and suppose you have a P controller. Suppose a P controller there. So what is the first what is the like this of the first P controller transfer function is normally your Kc, where Kc is your controller gain. Okay, Kp is your system gain and tau p is your system time constant. So this is the how will be the block diagram? It will be like this. So this will be, suppose, your controller. Suppose let us mark it as Gc. Yeah, let us mark it as Gc. So this will be your Gc. Then our final control element, let it be Gf. This will go to our system, that is our G of s. This will provide us our output, let it be Y of s. This we will measuring element Gm, and this will go, this is our input X of s. Okay, so like this. So now what will happen is that if you, okay, our slides have ended, no, okay, no problem. Now what will happen is that suppose you want to write the overall process transfer function, if you want to write it. So this will be in the format of, that Y of s by X of s. This is directly is equals to like sum of the forward loop. So forward loop transfer function is Gc Gf into Gs, and plus 1 plus this is your negative feedback, so plus minus, so plus your this like entire loop. Okay, so Gf, Gs, and your Gm. So open loop. Okay, so this is the forward loop divided by 1 plus open loop. So this will be our overall. So once this becomes our overall, so we can write it in this format, that let our Gf equals to our final control element equals to our, okay, the final control element we took it as Gf, no, wait 1 second, yeah, the final control element we took it as Gf, so no problem in that. So Gf will be is equals to, let it be Gm, and let all these things be equals to 1. So our Gs will be directly is equals to Gc into G of s, and divided by 1 plus, sorry, this is Gp of s, 1 plus Gc into G of s. Okay, and this the measuring element will also be there. Okay, like this. From this our Gc will be Kc, our G of s will be Kp by 1 plus tau ps, and divided by 1 plus, this is Kc, and this G of s will be again Kp by 1 plus tau ps. So overall this will become Kc Kp and divided by 1 plus tau ps and plus Kc Kp. Okay. Now if we want to move forward, just see here what is going to happen. Our GP of S will become KC KP and divided by let us take tau PS and plus 1 plus KP KC. We can write it like this way. Let us take our KC KP and make it 1 plus KP KC. Like we are just taking our KP KC common, okay? So tau P by 1 plus KP KC into S and plus 1. So this is in the format of our normal first order transfer function. This is in the format of our let this be our new process gain, that is your KP dash, and let this term be our new time constant, that is, wait one second, we can take some bright color, no, white, yes, that is our tau P dash. So now your new tau P dash becomes tau P by 1 plus KP KC. Okay, so now please understand that as your controller gain this KC increases, so your overall, that is your time constant of your entire process decreases. Okay, so that is why we say that when we use a proportional controller with our first order process, so the system becomes faster, the response becomes faster. Why the response becomes faster? Because this using your proportional controller will add a KC, and as this KC increases, this tau P, the new tau P dash, will go on increasing. This new tau P dash is the time constant for your system, like the time constant for this particular loop. Okay, where it went? Yeah, like this for this entire loop. It is the time constant. The new time constant will be tau P dash. Okay, so like this. So this is known as your dynamic response of your first order system. So this we just took for the example of the proportional controller. Many more things are there. Okay, offset is there. Many more things are there. So we will look into the very detail. Okay, like a very fast way we will look into this, and we will solve some questions also. So this is known as your dynamic response of your first order system. Okay, it is very important. Yeah, then we will be doing our stability analysis. Then we can move to our last topic, that is our controller tuning. And then there is your feed forward and your feed forward and your cascade control. So these are the main topics that we are willing to cover in our IPC subject. Okay, once our IPC subject is over, then we can move into our new subject, that is our heat transfer. Okay, let me write it here, or we can clean it up. We can clean it up, no, the old one. Yeah, let us clean it up. Okay, now let us start heat transfer. So we have already completed 3 of our major subjects, that is your third year subjects. Okay, all these subjects are your part of third year, no, like mass transfers, chemical reaction engineering, and your IPC, or somewhere it is called PDC. All these subjects you cover in your third year. So now let us focus in our second year subjects, like our heat transfer. So in heat transfer, the first thing we will be doing is our Fourier law. Okay, inside the Fourier law, we will be doing the general heat transfer equation. Like we will apply it to a flat plate, we will apply it to a cylinder, we will apply it to a sphere, we will apply it to internal heat generation conditions also, like a sphere along with a internal heat generation, a cylinder along with internal heat generation. All these things we will apply it. Okay, so these are the basic things. After that, we will be doing into lumped parameter model. Lumped parameter model, that is your Biot number, your Fourier's number, all these things we will look into. Okay, we will solve questions in it. Somewhere it is also known as transient heat conduction. So all these things we will be doing. Okay, after that we will be doing our convection. Under convection we will also do our heat exchangers, very important. After heat exchangers, then we will be moving to our radiation, and after radiation we will be doing our boiling and condensation. And we will end our subject with evaporators. Okay, in evaporators we will do all things like single effect evaporator, multiple effect evaporator, backward feed evaporator. Okay, then boiling point elevations, when we use backward feed evaporators, all these things we will be doing in our evaporator. Okay, so heat transfer. So 4 main subjects will be over. So our aim will be to complete these 4 main subjects. Okay, let us do some more. Let us complete our thermodynamics also. Let us look into our thermodynamics also. After heat transfer, we can do thermodynamics also, or if you want, then we can do fluid mechanics also. Okay, no worries. Let us do fluid mechanics. If you want, we can do fluid mechanics also. Like as per the discussion, we will have discussion as per the demand. We will be doing it. Okay, don't be worried. So suppose we do fluid mechanics. So as I have already discussed in the last lecture, the fluid mechanics for chemical engineering is very different for that of the mechanical and the civil department, as because the mechanical and the civil, they mainly focus on 2D and 3D flows, that is flow around structure, flow around curved surfaces, all these things. However, our main focus is 1D flow, and we are aligned with flow in pipes. Okay, very easy. So in fluid mechanics, the first thing is that fluid properties. In fluid properties, we will be dealing with the density and all these things. Okay, like the density, the bulk modulus, then compressibility factor, all these things. Okay, then we will look into viscosity, all these things, Newton's law of viscosity, special kind of fluids, non-Newtonian fluids. Okay, a surface tension. However, surface tension and all these things is not there in our syllabus. Still, okay, well, let us do one thing. First, let us do the topics that will be there in our syllabus. Then if time, after the completion of all these things, like the main syllabus, then we can do this miscellaneous topics. Okay, as I already said, that the course is announced as 100 hours, but if more time is required, then we can add it. Okay, if more time is required, then we can have the class of, instead of 2 hours, we can have classes of 3 hours also, as per your demand. And if required, then we can do more questions also. We can have more question sessions. We can have more doubt sessions. However, I will be clearing your doubts on the Telegram group. But still, if you want doubt sessions, if you want revision of any topic, if you want repetition of any other topic, so those things we can do. Okay, so let us write it 100 plus hours like this. Okay, so after that, we will just move into fluid kinematics. Fluid kinematics. Hydrostatics is there, but hydrostatics is okay. We will be doing hydrostatics is like in our chemical engineering, very less is there. Okay, so we will just look into it. The main thing is our fluid dynamics. The main thing is fluid dynamics. Under fluid dynamics, these three equations, no, the Euler's equation, the Bernoulli's equation, and your Navier-Stokes. And I know that many of you, like when I was a student, I was preparing for GATE, I was a student, and when I was in my B.Tech, all these things are very confusing, that what is a Navier-Stokes equation, it is so problematic. Okay, what is the difference between your Navier-Stokes equation, between your Bernoulli equation, between your Euler's equation, all these things are very confusing. But once we will cover it, it will just take it will take one class, like fluid dynamics, these three equations, we will complete it in one class. So once you follow the class, and it will be like very clear. It's just that we keep on applying the conditions. Okay, like if fluid dynamics is what we consider the forces and we neglect the motion. Okay, the forces are considered. So what are the primary kind of forces? This is your gravitational forces, your viscous forces, your pressure forces. Okay, these are the main kind of forces. Okay, so what is done is that this Bernoulli equation doesn't consider these viscous forces. However, the Navier-Stokes equation, this considers the viscous forces. So that is the main difference between your Bernoulli equation and your Navier-Stokes equation. Okay, so very easy. Once we will be doing it, it will be very easy. And from transfer from Euler's equation to Bernoulli equation, we just consider it to be steady state. Okay, like Euler's equation is valid for unsteady state also. However, Bernoulli equation is only valid for your steady state. So once we do that, apply that condition, steady state condition, so the Euler's equation directly gets converted into your Bernoulli's equation. So just this thing. Okay, so when we will be doing it exact details. You will be understanding it, and no doubts will be there after you attend this session of the fluid dynamics. Okay, so after fluid dynamics, then we will directly move to the most important topics, that is your flow through pipes. Flow through pipes. Under this, we will look into laminar flow, and we will look into turbulent flow. Okay, we will not waste much time here because these are only the main topics. Questions are going to come from this only. Yeah, in between, application of Bernoulli's theorem is there, that is your flow meters. Okay, this thing is there. Okay, one more thing is there, very important, that is your momentum equation. Momentum equation is there. So any question of your pipe flow, no, it is solved by just three equations. The first equation is your continuity equation, the second equation is your momentum equation, and the third equation is your that Bernoulli equation. If you apply these three equations, so any question of your pipe flow will be solved. Okay, you can take up the PYQ also. You can apply these three equations, so any question will be solved. Okay, under the momentum equation we will also look into jets. Okay, so no problem in that. So pipe flow, the main thing is that, and after that we will quickly look into your pump. Okay, how to solve the questions of your pump. NPS has so much confusion and all these things, and there we will just write down 3 steps, and with those 3 steps we will be solving all the questions of your pumps. Okay, so pumps is there, and after that, after pumps we will be looking into Cotte flow is there, but yeah, we can cover it. Like fluid mechanics we are doing it already at the last. No, we have already covered like the 4 major subjects, so fluid mechanics we can give it time, and Cotte flow also we will be doing. Okay, so these things are there. So this is the main idea of our fluid mechanics. So after the fluid mechanics, then we will be starting our this thing, what it is said, thermodynamics, the last major topic. Okay, so again in thermodynamics, it is again divided into 2 parts, that is your classical and your solution. Okay, so in the classical we will be dealing with our like zeroth law, that is our temperature. Many forms are there. Okay, like first law, in first law only many forms are there, and in this first law only I will define to you what are the heat capacities. Okay, what is your internal energy, what is the difference between internal energy and your intermolecular energy. Okay, so please okay, I can write it here also. So see, internal energy, no, it is like sum of your kinetic energy, potential energy, and intermolecular energy, that we denote it as U. So what we considered is that our kinetic energy and the potential energy are almost negligible. The changes are almost negligible. So okay, so from there we say that our internal energy is almost equal to our intermolecular energy. So that's why we write it as U everywhere. Okay, however, if the kinetic energy changes and the potential energy changes are mentioned, so we have to consider this also. Okay, then we will define our enthalpy. Okay, then we will be looking into different forms of our first law, like steady flow energy equation. First law applied to a steady flow process, first law applied to an unsteady flow process. All these things we will look into. Then we will look into second law, that is your directional law. What is the directional law? Like the first law just says that our heat transfer will occur. Like if there's a temperature difference and all these things, so our heat transfer is going to occur. If for conservation of energy, that as the total energy is always conserved, so this thing is going to occur, heat transfer is going to occur. But first law can never say the direction of the heat transfer. So what the second law does is that it uses the concept of our entropy, and it says the direction of the heat transfer. So that's why the second law is known as your directional law. So we will look into it, don't be worried. We will look into it. We will look into our heat engine. We will look into our refrigerator. We will look into our pumps. Okay, we will look into various cycles. Like in our syllabus, Carnot cycle is there. We will look into various processes like isothermal processes, isochoric processes, isometric processes, okay, adiabatic processes, and polytrophic processes. All these processes we will look into. We will look into the PV diagrams, the TS diagrams of these processes. Okay, on the second law only we will understand the concept of entropy, why entropy is important, all these things. What is entropy used for? Okay, entropy is used for like telling the feasibility of any process. Okay, so all these things we will be discussing, don't be worried. So these things are done, and after that what else is there in thermodynamics? Okay, TS equations and all these things are there. Thermodynamic relations, Maxwell's equation, very important. Maxwell's equations, many questions comes. Maxwell's equations. Okay, after Maxwell's equation, then we will look into, okay, like these are only the major topics. With this, if you understand these topics together, the main is the PV diagram and the TS diagram. If you understand the PV and the TS diagram properly, and you can understand the Carnot cycle and the Carnot diagram properly, so many things will become automatically easy. Okay, after that we will look into our solution thermodynamics. So solution thermodynamics is nothing, it is just based on your molar properties, the partial molar properties. Okay, the Gibbs-Duhem equation is there. Then it is just the relation between several properties. Okay, so after that what is there, in solution thermodynamics, what else is there? Okay, the residual property and the excess properties are there. Okay, then there is your I'm forgetting that, forgetting that name. Your, what is it? The activity constants is there. Okay, the Raoult's law, the modified Raoult's law, and the Raoult's law for real gases or the real liquids. All these things are there. So solution thermodynamics is very easy. Okay, so in thermodynamics, no, suppose 10 marks comes, so you can expect 3 marks from your classical thermodynamics and 7 marks from your solution thermodynamics. So like this is the division. So solution thermodynamics questions comes more, so we will focus on more on questions in case of solution thermodynamics. Like we will be doing theory also, like we will understand the concept and then directly we will solve some questions and all these things. Okay, so this was all about thermodynamics. So once we end thermodynamics, so our major subjects will be covered. Okay, all our 6 major subjects will be covered, and we will try to do it by the end of December. Like we are starting in 45, like we are starting 15th November, no, so in 45 days we are going to cover all these things. Okay, we will not take any days off of all like these things, and if required we can extend the timing of the classes also. So in just 45 days we will cover all these topics. Okay, once these topics are covered, then we will move to our next thing, that is our small the minor subjects, that is our PD, PC, PDE, PC and MO. So these are the numerical subjects. CT we will do at last, don't be worried. CT we will do at last, as because it is just a theoretical subject, and if we do it now there will be no benefit. You have to keep on revising it. Okay, so better than that, once we cover our all these 9 subjects, so at the end we will do our CT and you can just revise it after that. Okay, so time will be saved. So once we cover our major subjects, then we will jump into our PDE, our PC and our mechanical operation. So we can do it in the sequence, as we like syllabus is very less, we can cover it in like three classes each of 2 hours or 3 hours. We can do it. Okay, so that was the basic idea. So by 10th of January we will be trying to end our like crash course, and then we can have question solving sessions or practice sessions, so that we can have. Okay, so I will request everyone to subscribe, get the subscription. The new links and everything is over. The link for the subscription will be also provided in the description of this video, so go and get it. So not much of the advertisement. Don't forget to join the Telegram group for regular updates and all these things. Okay, the Telegram group is very important. There the regular updates and also the schedule will be posted. We will post our schedule also in the social media platforms, but still you can join the Telegram group. Okay, if you have any doubt, you can ask in the Telegram group also. Directly post it, don't be shy or all these things. Directly post your doubt, I will clear it. Okay, don't be worried. So yeah, so you get your subscription, you enjoy your Diwali. Like you can, I think you can hear the sound of that firecrackers and all. So enjoy your Diwali. The festive season will be over, and then from 15th November let us start with our full focus and full determination. Once we start in 15th November, we are not going to take any break. We will take break once we end our syllabus. Okay, yeah, so that was all for today's session. That was all for today's session. It was a very brief session, just to give you the information that how we are going to cover it, what are the topics that we are going to cover, and what are the content that we are going to cover. Okay, so we will solve basically theory, like concept. After that, first we will do concept. I will explain you the concept. Then from the concept we will come to our formula, and from that formula we will come to our question. This will be the basic sequence. Okay, like this. And after the questions, the doubts you will be having. So for doubts you can join directly the Telegram group. Doubt clearance we will be doing, and if questions and everything are required, you can do it, you can solve it. We will send you PYQs, get PYQs we will send you, so you can solve the get PYQs also. If you have any doubt in the get PYQs, you can post it, or else if you have any question from anywhere else, you can ask that also, doesn't matter. Okay, yeah, so thank you. Enjoy your Diwali. And please don't forget to join the sessions. Okay, after you join the session, I think if you are if you are already preparing from somewhere, then this will be a kind of revision session. You can just revise your concepts, and if your preparation is not that much good, then you must definitely join this session. This is going to benefit you. Even if you are in second year or your third year, you are not planning to give it this year get seriously, but still with this session you can get a very good rank. Okay, and your preparation will already be boosted for the next year's preparation. Okay, chalo. So thank you. Let us end this session. Let us not make it longer and all these things. Hope you all join this session, and then we can meet in the live class on 15th of November. Chalo, thank you.